Ladies and gentlemen, hello. This is going to be the last lecture for December, well, except for the example problems. And today we're talking about the different types, other types of radioactive reactions that we can have, all involving the nucleus of these elements. At first, we're going to talk about transmutation reactions. Let me make sure I got my pen set. While I'm doing that, when we talk about transmutation reactions, we're talking about those reactions that when we're changing an element by colliding another element together. So we're forcing a nucleus moving at high speed, and it hits a target element. And what happens is there's enough energy in that movement, in that element, nucleus that we're shooting at it, it actually fragments the other nucleus, and we make things. And we found out about these in the 1900s, and I'm going to show you two ones that we actually figured out where the actual part of the nuclei is Rutherford's experiment. And all they were doing is, and Chadwick's, all they were doing is taking helium alpha particles. Remember, this is an alpha particle. And they were hitting nitrogen gas. And when they were, at this time, they had spectroscopy, which means they can, looking at, and shone light through the gas chamber, and figured out, besides nitrogen, they saw fluorine being produced, and then oxygen. And they were able to capture these guys, which are protons. Remember that it's 1,1p. There's another way to write this. So if we look at this, if we look at this side, 14 plus 4, that's going to be 18. 7 plus 2 is 9. So, and then we have this decay, 18. 17 plus 1, that's 18. 8 plus 1 is 9. So everything's balanced. And here we have the evidence of protons. Notice what we start with, the mass number, 18. 7 plus 2 is 9. We should have this on this side. 17 plus 1 is 18. 8 plus 1 is 19. And there we go. That's the sum. This number came from this plus this. 18 came from this plus this. So they're not just one element. This is the sum of both of those. And we'll point out to Chadwick, he did the same thing, but he used aiming alpha particles at beryllium. And he ended up, notice we had carbon, and something else was coming out. These particles couldn't be affected by either magnetic field or electrical fields, so they're called neutrons, and they actually had mass. And so Chadwick was able to discover the presence of neutrons. And those are, so neutron, proton, and electron are the three particles, subatomic particles that we know of the atom. Now, what I'm going to be asking you to do is solve these things. So we have this element. Off the top of my head, it's 96 cm is curium. I almost said californium, which I know that's not right. Is at CF. This is curium. It's being shot with a atomic carbon nucleus, and we're getting 4 neutrons back. So how to solve this? Take the mass number, 246 plus 12, that gave me 258 for the sum. That's this plus this. And that 258 is going to equal X, what we don't know, plus 4. Because we've got 4 neutrons coming out. So that's 1 times 4 is 4. So what is X? So X is going to be 258 minus 4, which is 254. So 254 is going to be my mass number. Now, folks, I will always, if there's more than 1 neutron being ejected, I'll give you that. I'm not going to have you figure out how many neutrons is being emitted. I don't think that's that at this point of your career, you don't know how to figure that one out. Oh, keeping it easy for you. So atomic number. 96 plus 6 gives me 102. Neutrons don't have any atomic number. So this element is going to be 102. And so 102 is nobelium, or NO. And this is what transmutation reaction does. And this is the right answer. So let's continue. Fusion is like transmutation, but it's a special process. I'm going to underline special because it's where two atoms must be of the same element, like two hydrogens or two heliums. So with this fusion is coming in, it's very to transmutation, but we're taking hydrogen plus hydrogen, and we get deuterium plus positron being emitted. This is fusion. Two elements coming together, and they're the same element. All right, I forgot to delete this slide, but basically hydrogen plus hydrogen will get deuterium. Then you part of the process, you can get two deuteriums to form tritium. And you get a proton emitted. And then tritium plus tritium, you're going to get helium. And you're going to get two neutrons. If I get that right, yes. So those are the three reactions, and they're all fusion. Remember, all these: hydrogen, deuterium, which is D, tritium, which is T, all the same element, just different isotopes. Hydrogen is the only element that has more than one chemical symbol. Now, fission is a decay that is going to, because you're breaking down an element, but it's enhanced by a bombardment of a neutron. And we stress neutron. And what happens is we get a production of neutrons, and we end up having a chain reaction. So here's an example. We have uranium neutron hitting uranium-235. It quickly forms uranium-236. Then this is so unstable, it breaks apart to these two elements, barium and krypton, plus 3 neutrons. And this is what I mean by a chain reaction. So we have 1 neutron, and we end up with 3 neutrons. Neutron, neutron, neutron. So 1 to 3. Now each of these will produce 3. So 3 times 3 is 9. Then this 9 will produce 27, and so on and so forth until we get a huge number after about 4 or 5 collisions. This is what we mean by chain reaction. And it's going to happen fast and quickly, and we end up with a boom. And a lot of energy produced. And so this is what happens in nuclear reactors. We actually have beryllium and some other boron to absorb all these neutrons to help keep the reaction under control. And nuclear weapons don't have that, so they go boom. This is now the end of the lecture. If you have any questions, let me know. And I'll also post another slideshow on how to do the examples.